Throughout human history, we've engineered weapons of immense power, capable of reshaping landscapes and ending civilizations. We call them nuclear bombs. But what if I told you that nature possesses a weapon far more powerful? A force that has shaped our planet for billions of years and could one day threaten our very existence? We're talking about supervolcanoes. In a cosmic showdown of destructive force, which one truly holds the ultimate power? Our own creation or the Earth's inner fury? Let's start with what we know best. The atom bomb. The bomb dropped on Hiroshima, little boy, was devastating. It released energy equivalent to about 15 kilotons of TNT. That single explosion flattened a city and ended tens of thousands of lives in an instant. The largest nuclear weapon ever detonated, the Soviet Union's Tsar Bomba, was a monster by comparison. Exploding with a force of 50 megatons, that's over 3,000 times more powerful than Hiroshima. It sent a mushroom cloud soaring into the stratosphere and a shock wave that circled the globe 3 times. The immediate effects are horrifying: a blinding flash of light, a thermal pulse that vaporizes everything nearby, and a blast wave that pulverizes buildings for miles around. But the horror doesn't end there. The lingering effect is radioactive fallout. These tiny invisible particles are carried by the wind, contaminating land, water, and air for decades, even centuries. A full-scale nuclear war involving thousands of these weapons would trigger a nuclear winter. The immense amount of smoke and soot lofted into the atmosphere would block out the sun, causing global temperatures to plummet. Crops would fail, ecosystems would collapse, and humanity would face a fight for survival in a dark, frozen world. It's a self-inflicted apocalypse, a testament to our capacity for destruction. Now let's turn our attention to nature's contender. Supervolcanoes aren't your typical cone-shaped mountains. They're massive depressions in the Earth's crust called calderas, sitting atop gigantic pools of magma. Yellowstone National Park in the United States is perhaps the most famous example, a beautiful landscape masking an unimaginable threat. When a supervolcano erupts, it's not a gentle flow of lava. It's a cataclysmic explosion that dwarfs any nuclear weapon we've ever conceived. To understand the scale, let's look at the Volcanic Explosivity Index, or VEI. It's a scale from 0 to 8. The 1980 eruption of Mount St. Helens was a VA 5. The devastating eruption of Mount Tambora in 1815 was a VA 7. A supereruption is a VA 8. The last one was the Toba eruption in Indonesia about 74,000 years ago. It ejected nearly 3,000 cubic kilometers of rock and ash into the atmosphere. To put that into perspective, the Tsar Bomba's explosive yield was 50 megatons. The Toba eruption is estimated to have been equivalent to 1 million megatons. That's 20,000 Tsar Bombas going off at once. The immediate impact of a supereruption would be biblical. A pyroclastic flow, a superheated cloud of gas, ash, and rock traveling at hundreds of miles per hour, would incinerate everything within a radius of hundreds of miles. Entire states or even small countries would be buried under meters of hot ash. The blast itself would be heard around the world. Anyone in the immediate vicinity would have no chance of survival. The scale of instantaneous destruction is almost impossible to comprehend. Just like a nuclear war, the long-term effects are global. A supereruption would pump enormous quantities of sulfur dioxide and ash into the stratosphere. This aerosol cloud would encircle the planet, reflecting sunlight back into space and triggering a volcanic winter. Global temperatures would drop dramatically, potentially by 5 to 10 degrees Celsius for years. This would lead to widespread crop failures, famine, and the collapse of ecosystems. The Toba eruption is believed to have pushed early humanity to the brink of extinction, creating a genetic bottleneck from which we barely recovered. It was a planetary reset button, pushed by the Earth itself. So, who wins this terrifying contest? Let's compare them side by side. For immediate destructive power, a single supereruption is the undisputed champion. No man-made weapon comes close to the sheer energy released by a VA8 event. The immediate blast zone is larger, and the volume of material ejected is astronomical. A nuclear bomb is like a surgical strike of immense power. A supervolcano is like a planetary shotgun blast. When it comes to long-term global impact, the two are frighteningly similar. Both a nuclear winter and a volcanic winter would plunge the world into a prolonged period of cold and darkness, leading to mass starvation and societal collapse. The key difference is the type of fallout. Nuclear winter brings with it the persistent, deadly threat of radiation, poisoning the gene pool for generations. Volcanic winter only brings ash and acid rain, which, while devastating to agriculture and infrastructure, eventually clears. However, the sheer volume of ash from a supereruption would physically bury vast areas of the planet, making them uninhabitable and unfarmable for a very long time. So here's the final verdict. In terms of raw, explosive power in a single event, the supervolcano is in a league of its own. It's the most powerful destructive force on our planet. However, the horror of nuclear weapons lies in their accessibility and their uniquely poisonous legacy. There are thousands of them controlled by humans, capable of being unleashed at a moment's notice. The radioactive fallout adds a layer of generational terror that even a volcano cannot match. While a supervolcano is a low probability, high-impact natural disaster we can only prepare for, nuclear war is a high-impact disaster of our own making, a choice we could actively make. One is a force of nature we must respect and monitor. The other is a reflection of our own inner demons we must control. Both scenarios paint a grim picture of a world undone, a stark reminder of the fragile thread upon which our civilization hangs. Understanding these ultimate threats isn't about fear, it's about perspective. It encourages us to appreciate the stability we often take for granted and to work together to mitigate the risks we can control, ensuring that our own inventions don't become the final chapter in the human story. Before we continue this story, subscribe to the channel. Your support helps us tell the true stories of Earth's most powerful volcanoes. The immediate blast wave crushes buildings within miles. The thermal radiation ignites everything flammable. Fires merge into firestorms that consume oxygen itself, suffocating those who survive the initial explosion. Then comes the radiation. Invisible. Insidious. It doesn't kill instantly like the blast. It kills slowly. Days, weeks, months. Radiation sickness destroys your body from the inside. Your cells stop dividing. Your immune system collapses. You bleed internally. Hair falls out. Organs fail. The survivors of Hiroshima and Nagasaki called themselves Hibakusha, the explosion-affected people. Decades later, they still bore the scars, cancers, birth defects, genetic damage passed to children who weren't even born when the bombs fell. And yet, for all its horror, nuclear war remains hypothetical. Threatened, feared, but never fully unleashed. We've detonated over 2,000 nuclear weapons in tests. We've mapped every consequence, calculated every casualty projection, built enough warheads to destroy civilization several times over, but we haven't done it. The bombs sit in their silos, sleep in their submarines, wait in their bunkers, silent, patient, terrible. And perhaps that's the most important thing to understand about nuclear weapons. They're a choice. A human choice. We built them. We control them. We can choose not to use them. Every nuclear detonation in history happened because someone decided to press a button, to turn a key, to give an order. They don't erupt on their own. They don't awaken from centuries of sleep. They don't reshape continents according to forces we can't control. But volcanoes answer to no one. They sleep when they choose. They wake when they choose. And when they do wake, they don't ask permission. They don't require a chain of command or a launch code. They simply erupt, and the destruction they cause, the years of darkness, the global famines, the civilizations toppled, they achieve all of that without any intent. Without malice, without even knowing we exist. So yes, we've created weapons of unimaginable power. We've split the atom and harnessed the sun's fury. But the Earth? The Earth has been doing this far longer than we've existed. And on a scale that makes our most powerful weapons look like firecrackers. Yellowstone National Park. 3,000 square miles of geysers, hot springs, and pristine wilderness. Every year, 4 million visitors walk its trails, photograph its wildlife, marvel at Old Faithful's clockwork eruptions. Beneath their feet lies something they cannot see. A magma chamber. 37 miles long, 18 miles wide, 5 miles deep. Enough molten rock to fill the Grand Canyon 11 times over. This is a supervolcano and it's not extinct. It's sleeping. The last time it fully awakened 640,000 years ago, it ejected 240 cubic miles of rock and ash into the atmosphere. The eruption column rose over 30 miles high. Ash blanketed half of North America. They found deposits in Louisiana, in California, in the Gulf of Mexico. Entire species vanished. The Earth's climate shifted for years. And here's what keeps geologists awake at night. It's happened before. 3 times. Like clockwork, roughly every 600,000 years. We're overdue. But Yellowstone is just one. Lake Toba, in Indonesia. 74,000 years ago, it erupted with such violence that it nearly ended humanity itself. The genetic evidence is still there in our DNA, a bottleneck. A moment when the human population crashed to perhaps 10,000 individuals. We came that close to extinction. 6 years of volcanic winter. Temperatures dropping 20 degrees. Crops failing worldwide. Our ancestors huddled in caves, clinging to survival by their fingernails. One volcano, one eruption. And we almost didn't make it. Now you might be thinking, but that was 74,000 years ago. We're different now. More advanced. We have technology, warning systems, we can evacuate, we can prepare, can we? Consider this. When Mount Pinatubo erupted in 1991, scientists had months of warning. Seismometers detected the earthquakes. Gas emissions showed the magma rising. They evacuated 60,000 people from the surrounding area. And still, 800 died. Thousands more lost everything. The ash and rain created lahars, volcanic mudflows that buried entire towns under 30 feet of mud. Pinatubo ejected 2.5 cubic miles of material. A significant eruption, yes. Catastrophic for those nearby. But compared to a supervolcano, Pinatubo was a firecracker. A full Yellowstone eruption would be 100 times larger. Perhaps 1,000 times, depending on how long it had been building pressure. The ash cloud wouldn't just blanket half a continent. It would encircle the globe within days. Jet streams would carry it everywhere. The sun would dim. Photosynthesis would slow, crops would fail, not just in Wyoming. Not just in America. Everywhere. The global food supply would collapse within months. Modern agriculture depends on predictable weather, on sunshine, on specific temperature ranges. Take that away, and our just-in-time delivery systems, our supermarkets, our supply chains, they all crumble. We like to think we've mastered nature. We've built cities that scrape the clouds, we've connected the entire world with invisible networks. We've even left our footprints on the moon. But we still eat food that grows from dirt. We still breathe air, we still need the sun. And a supervolcano can take all of that away for years. Here's what the Tsar Bomba couldn't do. It couldn't block out the sun. Yes, the initial blast was catastrophic. Yes, the fireball was enormous. But within hours, the immediate destruction was complete. The atmosphere cleared. Life, however damaged, could begin to recover. A supervolcano works differently, slower, more patient. The eruption itself might last days, weeks. Ash continues to pour into the atmosphere. Each cubic mile of ejected material adds to the veil. The Earth's temperature drops degree by degree. The first growing season fails. Then the second. Then the third. Famine doesn't announce itself with a flash of light, it creeps. It spreads. It compounds. After the 1815 eruption of Mount Tambora, which was only 1/10 the size of what Yellowstone could produce, Europe experienced the year without a summer. Snow fell in June. Crops failed across the northern hemisphere. Tens of thousands starved. Now multiply that by 10, by 20. Imagine not 1 year without a summer, but 5. 10. Imagine our modern world's 7 billion people. Most living in cities dependent on global food networks trying to survive that. The Tsar Bomba could destroy a city. Perhaps several cities if we built enough of them. But a supervolcano? A supervolcano could destroy civilization itself. Not through immediate violence, but through the slow, inexorable collapse of everything we've built. And unlike nuclear weapons, we can't disarm a volcano. We can't negotiate with it. We can't choose not to use it. It chooses. According to rhythms older than our species. According to pressures building in the deep earth, far beyond our control. We monitor it. We measure it. We watch the ground rise and fall as magma moves beneath Yellowstone. We track every earthquake, every gas emission, every thermal change. But if it decides to wake, there's nothing, absolutely nothing we can do to stop it. The invisible killer. When we imagine destruction, we think of fire, of explosions, of buildings collapsing and cities burning. We think of something we can see, but the deadliest force from both nuclear weapons and volcanic eruptions is something invisible. Something that hangs in the air. Something that blocks the sun. Particulates. After the Tsar Bomba detonated in 1961, scientists measured the fallout. Radioactive particles strontium-90, cesium-137, iodine-131 spread across the northern hemisphere. They settled into soil, contaminated water supplies, entered the food chain. For years afterward, children drinking milk in Norway, in Alaska, in Japan, absorbed radioactive isotopes that hadn't existed in nature before we created them. But here's the crucial difference. Radioactive fallout, deadly as it is, degrades over time. Half-lives tick away. Cesium-137 loses half its radioactivity every 30 years. Strontium-90, 29 years. Within decades, perhaps a century, the most dangerous isotopes decay to safer levels. The land heals, slowly, painfully, but it heals. Volcanic ash doesn't decay. It doesn't lose potency. It doesn't become less dangerous with time. It simply falls and falls and falls. When Mount Tambora erupted in 1815, it ejected 36 cubic miles of ash and pumice into the stratosphere. The eruption column reached 28 miles high, well above the weather systems, above the rain clouds that might have washed it down quickly. Up there in the stratosphere, the ash spread. Currents carried it east and west. Within weeks, it had formed a veil around the entire planet. Sunlight dimmed. Global temperatures dropped 1 degree Celsius. That might not sound like much, 1 degree. A barely noticeable change. But agriculture operates on razor-thin margins. 1 degree cooler means the growing season shortens by weeks. Crops that need 120 frost-free days don't get them. Rice paddies in China fail. Wheat fields in Europe produce half their normal yield. Monsoons shift. Droughts strike where rain should fall. The famine that followed killed more people than the eruption itself. Far more. In Indonesia, where Tambora stood, 90,000 died from the immediate eruption and its aftermath. But worldwide? Hundreds of thousands. Perhaps millions. We'll never know the true count because record keeping in 1815 wasn't comprehensive. We only know that people starved. From Ireland to India. From New England to the Yangtze Valley. All because of particles suspended in the upper atmosphere. Now imagine something 10 times worse. A full Yellowstone eruption wouldn't just dim the sun. It would block it. For months. Perhaps years. The ash cloud from a supervolcano doesn't just spread, it accumulates. Layer upon layer, each day's eruption adds to yesterday's veil. The sun becomes a pale disk. Then a smudge. Then nothing. Plants die first. Not from the ash itself, but from the darkness. Photosynthesis slows. Then stops. Forests begin to wither. Grasslands turn brown. Then the herbivores starve. Deer, cattle. Everything that depends on vegetation. Then the carnivores. Then us. Modern civilization has built elaborate systems to protect us from nature. Climate-controlled buildings. Greenhouses. Indoor farming. These might help, yes. Might buy us time. But they all require energy. Electricity. And where does that electricity come from? 70% of global electricity still depends on fossil fuels or nuclear reactors that need cooling water in supply chains. Solar panels covered in ash don't generate power. Wind turbines in a stagnant, ash-choked atmosphere don't turn. The grid fails. And when the grid fails, modern life fails. Food production collapses. Water treatment plants shut down. Hospitals lose power. Communication networks go dark. This is what volcanic winter means. Not just cold. Not just darkness. Complete systemic failure. And here's the terrifying part. We've never experienced one in the modern era. Never tested our supply chains, our infrastructure, our social systems against years of darkness. The last supervolcanic eruption occurred 74,000 years ago. Humans were hunter-gatherers. Small bands, mobile, adaptable. When the food ran out in one place, they moved to another. Where can 7 billion people move? A nuclear winter, the theoretical catastrophe from multiple nuclear weapons igniting cities, worldwide would create similar conditions. Smoke from burning cities rising into the stratosphere. Sunlight blocked. Temperatures plummeting. But nuclear winter requires one thing: someone has to start it. Someone has to launch the missiles, turn the keys, make the decision. It's a human choice. Volcanic winter isn't. Nature doesn't ask permission. It doesn't consider consequences. It simply responds to pressure building in the mantle, magma chambers filling, tectonic forces grinding against each other for thousands of years. When the pressure becomes too great, the Earth opens. And we can't stop it with treaties. Can't deter it with weapons. Can't negotiate a ceasefire. We can only watch, measure, hope, and prepare for something we've never prepared for before. Because the ash doesn't care about borders, doesn't discriminate between nations, doesn't spare the innocent or punish the guilty. It falls on everyone, equally, relentlessly, until it's done. The illusion of control. Los Alamos, New Mexico. 1945. The world's brightest physicists gathered in the desert to build the first atomic bomb. They called it the Manhattan Project. A race against time, against Nazi Germany, against the possibility that someone else might harness the atom first. Robert Oppenheimer led the team. Brilliant, haunted. After the first successful test, the Trinity test, he would later recall a line from Hindu scripture. Now I am become death, the destroyer of worlds. They knew what they'd created. They understood the mathematics, the chain reactions, the yield calculations. They could predict, down to the kiloton, how powerful their weapon would be. They controlled it. That control is what makes nuclear weapons uniquely human. We decide when to build them, where to store them, whether to use them. Every warhead in existence sits waiting for a human decision. 60,000 nuclear weapons have been built since 1945. 60,000. Today, approximately 12,700 remain. Still too many to contemplate. Still enough to destroy civilization several times over. But here's the crucial fact. In 80 years, despite wars, despite tensions, despite close calls that brought us to the brink, we haven't used them again after Nagasaki. Not because we couldn't. Because we chose not to. During the Cuban Missile Crisis in 1962, the world came within a heartbeat of nuclear war. Soviet submarines, hunted by American destroyers, carried nuclear torpedoes. The commanders had authorization to use them if they believed war had begun. On submarine B-59, 3 officers had to agree unanimously to launch. 2 agreed. 1 Vasily Arkhipov refused. 1 man, 1 decision. The world continued. That's control. Imperfect. Terrifying, but control nonetheless. Now consider Yellowstone. Scientists monitor it constantly. The Yellowstone Volcano Observatory tracks thousands of data points. Seismometers detect every tremor. GPS stations measure ground deformation down to the millimeter. Gas sensors analyze sulfur dioxide emissions. We have more instruments watching Yellowstone than we have watching most nuclear arsenals. And still, we can't control it. Not even remotely. In 2014, the ground near Norris Geyser Basin rose 4 inches in a single year. Magma moving beneath the surface. Pressure building. Thousands of small earthquakes rippled through the park. Scientists watched, measured, analyzed. Then the activity stopped. The ground settled. The earthquakes diminished. Why? We don't know. Not really. The magma chamber does what it does according to forces operating on timescales we barely comprehend. Thousands of years, millions of years. Plate tectonics grinding away. Mantle plumes rising from thousands of miles below. We can observe, we cannot control. In 2010, Indonesia's Mount Merapi began showing signs of unrest. Scientists evacuated 350,000 people from the danger zone. The largest volcanic evacuation in history. Merapi erupted. 353 people died, mostly those who refused to leave. The evacuation saved hundreds of thousands of lives, a success story by any measure. But here's what they couldn't do. They couldn't stop the eruption. Couldn't delay it. Couldn't redirect the lava flows or prevent the pyroclastic surges. All they could do was move people out of the way. Now imagine trying to evacuate everyone within 600 miles of Yellowstone. That's not 350,000 people. That's millions. Denver, Salt Lake City, Boise, major metropolitan areas. Where would they go? How would they get there? Who would house them? Feed them? And for how long? Because unlike a nuclear attack which delivers its destruction in hours and then ends, a volcanic eruption can continue for weeks, months, years in some cases. The Laki eruption in Iceland, 1783, lasted 8 months. 8 months of continuous lava flows. 8 months of toxic gas releases. The eruption killed 20% of Iceland's population. The gases drifted to Europe, creating a toxic fog that killed thousands more. You can't evacuate for 8 months. Civilization doesn't have the capacity, the logistics, the resources. At some point, people would have to return home. Or try to. And that's assuming the eruption follows a predictable pattern. That it doesn't suddenly intensify. That it doesn't shift to a different style from lava flows to explosive eruptions. That the wind doesn't change direction and carry ash to areas previously thought safe. Volcanoes don't follow scripts. This is what separates human-made catastrophes from natural ones. We built nuclear weapons, we can choose to dismantle them. We've already reduced the global stockpile by 78% since the peak of the Cold War. We didn't build volcanoes, we can't dismantle them. Can't reduce their power. Can't negotiate limits or sign treaties restricting their activity. The Earth doesn't negotiate. It simply is. And perhaps that's the most humbling realization of all. For all our technology, all our scientific understanding, all our ability to split atoms and reach into space, we remain in the face of geological forces, fundamentally powerless. We can predict. Sometimes we can prepare. Inadequately, we can hope. Always? But control? That's an illusion we tell ourselves to sleep better at night. The magma beneath Yellowstone doesn't care about our plans. Doesn't consult our calendars. Doesn't wait for convenient moments. When the pressure becomes too great, it will release. And we will watch and measure. And do our very best to survive what we cannot prevent. The mathematics of annihilation. Numbers can be deceptive. 50 megatons sounds enormous, and it is. The Tsar Bomba's 50 megaton yield represents more explosive power than all the conventional weapons used in World War II combined. Every bomb dropped on London. Every shell fired at Stalingrad. Every grenade thrown in the Pacific Islands. All of it combined, then multiplied, one weapon. But let's talk about what 50 megatons actually means in terms of energy. 210 petajoules. That's the scientific measurement. 210,000 trillion joules of energy released in a fraction of a second. Incomprehensible. Let's make it tangible. The fireball from the Tsar Bomba, 5 miles in diameter, vaporized everything within it. The thermal radiation would have caused third-degree burns to anyone within 60 miles. The blast wave destroyed wooden houses 100 miles away. If it had been detonated over a major city, say New York, the entire metropolitan area would have ceased to exist. Manhattan, Brooklyn, Queens, the Bronx gone, Newark, Jersey City. Everything within the immediate blast radius simply erased. The death toll would have been measured in millions. Immediate deaths. Perhaps 8 million people in the first few hours. Now let's compare that to Yellowstone. The Huckleberry Ridge eruption, Yellowstone's largest, 2.1 million years ago, ejected 600 cubic miles of material. To put that in perspective, imagine filling up 2 million Olympic-sized swimming pools with rock, ash, and pumice, then launching all of it 30 miles into the atmosphere. Scientists estimate the energy released was approximately 2,500 times greater than the Tsar Bomba. 2,500 times. But here's where the numbers become truly revealing. It's not just about total energy. It's about how that energy is distributed, how long it lasts, what it does to the planet. A nuclear explosion releases its energy in 3 ways: blast, thermal radiation, and nuclear radiation. Roughly 50% goes into the blast wave, 35% into thermal radiation, 15% into various forms of nuclear radiation. It happens in seconds, devastating seconds, yes. But seconds, then it's over. A volcanic eruption distributes its energy differently. The initial blast, the explosive decompression when the magma chamber ruptures, is only the beginning. Lava flows continue for weeks, months, pouring millions of tons of molten rock across the landscape at temperatures exceeding 1,000 degrees Celsius. Pyroclastic flows, superheated avalanches of gas and rock race down slopes at hurricane speeds. They don't just destroy buildings, they incinerate everything organic. Turn forests into charcoal in seconds. Bury valleys under hundreds of feet of volcanic deposits. And the ash. Always the ash. The 1980 eruption of Mount St. Helens ejected 1 cubic kilometer of material. The ash cloud traveled across 11 states. Spokane, Washington, 250 miles away, received half an inch of ash, enough to close the city, collapse roofs, clog engines, contaminate water supplies. Now multiply that by 600. 600 cubic miles versus 1 cubic kilometer. Yellowstone wouldn't just affect 11 states. The ash would blanket the entire continent. 6 inches deep in Wyoming, 3 inches in the Dakotas. 1 inch as far east as the Mississippi River. And that's just the immediate fallout. The fine particulates, microscopic fragments of glass and rock, would remain suspended in the stratosphere for years, circling the globe, reflecting sunlight back into space. This is where the nuclear comparison becomes most stark. A nuclear winter, according to climate models, would result from approximately 100 megatons of material, smoke, soot, and debris reaching the stratosphere from burning cities. 100 megatons of particulates. A Yellowstone eruption would inject thousands of megatons into the atmosphere. Not smoke. Not soot. Volcanic ash. Sulfur dioxide. Materials that persist longer, reflect sunlight more efficiently. The temperature drop wouldn't be temporary. Wouldn't last months, years, potentially decades before the climate fully stabilized. Agricultural production worldwide would collapse. Not reduced, collapsed. Current models suggest global crop yields would drop by 90% in the first year. 90%. 7 billion people, most living in cities, dependent on complex supply chains that deliver food from farms to supermarkets just in time. Remove 90% of the food supply, and what happens? The mathematics are brutal. Even with perfect distribution, which would never occur even with every resource mobilized for survival, we couldn't feed everyone. Billions would face starvation. Not would. The Tsar Bomba could kill millions in an instant. A horrific number. Unthinkable. But a supervolcano could kill billions slowly. Through starvation. Through the cascading collapse of systems we've built and depend upon. And here's the final cruel calculation. We've built approximately 12,700 nuclear weapons. If every single one were detonated, an apocalyptic scenario beyond reason, the total yield would be approximately 3,000 megatons. 3,000 megatons of immediate destruction. Yellowstone, in a single eruption, could release energy equivalent to 25,000 megatons. Sustained over weeks or months. Distributed across an entire hemisphere. The numbers don't lie. In terms of pure destructive energy, in terms of climate impact, in terms of long-term consequences for human civilization, the volcano wins. Not because it's more violent in the moment, but because it doesn't stop. The human cost. Hiroshima, August 7, 1945. One day after the bomb, Dr. Michihiko Hachiya walked through streets he no longer recognized. He was the director of the Hiroshima Communications Hospital. He had survived the blast, though injured. What he recorded in his diary would become one of the most haunting documents of the nuclear age. People wandered like ghosts, skin hanging from their arms in sheets. Eyes swollen shut, begging for water. So many begging for water. The hospital, what remained of it, overflowed with wounded. Burns covering 90% of their bodies. Radiation sickness already beginning. Victims vomiting, bleeding from their gums, their noses, their eyes. They died by the hundreds. Then the thousands, not from the blast. Not from the heat. From injuries the doctors couldn't treat. Couldn't even understand fully. This is what nuclear weapons do to people. To individuals. To mothers and fathers and children who happened to be in the wrong place when someone, thousands of miles away, made a decision. The immediate deaths are actually the merciful ones. Those who survived the initial blast face something worse. Acute radiation syndrome. Their cells stopped dividing. Their bone marrow ceased producing blood cells. Their immune systems collapsed. Some died within days. Others lingered for weeks, months. And those who survived even that? They carried invisible scars, genetic damage, increased cancer rates that would plague them for decades. Children born with deformities. Leukemia clusters that appeared years later. The hibakusha, the survivors, became living reminders of what atomic weapons truly mean when you strip away the technical language and the megaton calculations. They mean suffering, prolonged intergenerational. Now let's talk about Pompeii. August 24th, 79 Mount Vesuvius erupted. The city of Pompeii, 6 miles from the volcano, thought itself safe at first. They'd felt earthquakes before, seen smoke rising from the mountain, Then the pyroclastic surge came. A superheated cloud of gas and pulverized rock, moving at 100 miles per hour. Temperature: over 500 degrees Celsius. Death was instant. Bodies frozen mid-motion. A mother clutching her child. A man covering his face. A dog straining against its chain. 2,000 people died in Pompeii. Another 1,000 in Herculaneum. Entire cities preserved in volcanic ash, their final moments captured for eternity. But here's what we often forget. Pompeii was a relatively small eruption. A V5 on the Volcanic Explosivity Index. Significant, yes. Deadly, absolutely, but small compared to what the Earth is capable of. Mount Tambora, 1815. V7, 71,000 people died on the island of Sumbawa. Not instantly, like Pompeii. The eruption lasted for days. Pyroclastic flows. Tsunamis generated by volcanic material hitting the sea. Ash burying entire villages. Then came the aftermath. Crops failed. Water sources contaminated. Famine spread across Indonesia. Disease followed famine. Cholera. Dysentery. The death toll climbed. 90,000 on Sumbawa alone. But worldwide? The famine triggered by the year without a summer killed hundreds of thousands more. Families in Switzerland so desperate they ate grass. Irish peasants, already on the edge, pushed into starvation. Chinese rice farmers watching their paddies produce nothing. They had no idea why. Didn't know about a volcano erupting on a distant island. Didn't connect the strange cold summer to geological forces half a world away. They just knew their children were dying. This is what makes volcanic catastrophes different from nuclear ones. Nuclear weapons kill with intention. Terrible intention, yes. Criminal intention. But there's a human element. Someone to blame, someone to hold accountable. Volcanoes kill with indifference, no malice, no intent. Just geological processes playing out over timescales that make human lives seem like heartbeats. The magma doesn't care that a village sits on the slope. Doesn't consider the family sleeping in their beds. Doesn't pause for evacuation orders. It rises because pressure demands it. And when we talk about a supervolcano like Yellowstone, we're not talking about 2,000 deaths or 70,000, or even hundreds of thousands. We're talking about the potential end of billions of lives, not instantly. That would almost be kinder. Slowly. Through starvation. Through the collapse of supply chains that feed 7 billion people. Through the breakdown of social order when food becomes scarce. Through conflicts over remaining resources. Through parents watching their children go hungry and being powerless to help. That's the true horror. Not the eruption itself. Not the spectacular destruction. The slow unraveling of everything afterward. When the Tsar Bomba detonated over the Arctic, it killed no one. It was a test, a demonstration, a weapon that never touched civilian populations. But if Yellowstone erupts when it erupts, there will be no warning adequate to save everyone. No evacuation plan comprehensive enough. No food stores deep enough. People will die in the blast zones. Yes, but far more will die in the months and years that follow. In refugee camps overwhelmed by millions fleeing the ash. In cities where grocery stores run empty and never restock. In hospitals without power, without medicine, without hope. And unlike the victims of Hiroshima and Nagasaki, whose suffering we can at least acknowledge, memorialize, learn from the victims of a supervolcano won't have monuments. They'll just be gone, numbers in historical records. If there are still historians left to record them. The verdict. So here we stand at the end of our comparison. Two forces, both capable of ending civilizations. Both terrible beyond imagination. On one side, human ingenuity turned dark. The power of the atom harnessed and weaponized. Bombs that can vaporize cities in seconds. Radiation that poisons for generations. On the other, the Earth itself. Magma chambers building pressure for millennia. Supervolcanoes that dwarf our most powerful weapons. Forces that operate on timescales beyond human comprehension. Which is more destructive? The answer depends on how we measure destruction. In immediate violence, in sheer explosive force concentrated in a single moment, nuclear weapons win. Nothing humanity has ever created can match the instant devastation of a 50-megaton detonation. The Tsar Bomba remains the single most powerful explosive device ever detonated. Its fireball, its blast wave, its thermal pulse unmatched in concentrated fury. But if we measure destruction by total energy released, by climate impact, by the potential to end not just cities but entire civilizations, the volcano wins, decisively. A single Yellowstone eruption would release energy equivalent to 1,000 Tsar Bombas, sustained over weeks or months, distributed across continents. The ash alone would fundamentally alter Earth's climate for years, perhaps decades. Global temperatures would plummet, agriculture would collapse, billions would face starvation. And here's the crucial distinction. Nuclear war requires a decision, a human choice. Every warhead in existence sits waiting for someone to turn a key, enter a code, give an order. We can choose not to. For 80 years, despite tensions, despite close calls, despite enough weapons to destroy the world several times over, we haven't used them. Deterrence works. Mutually assured destruction, as grim as it sounds, has kept the nuclear arsenal silent. But Yellowstone doesn't deter. Can't be negotiated with. Won't respond to treaties or diplomacy. It will erupt when geological forces demand it. When the magma chamber reaches critical pressure. When the crust above can no longer contain what's building below. Not if. When the last eruption was 640,000 years ago. The cycle suggests we're overdue. Not this year. Not next year. But in geological terms tomorrow. And when it happens, all our technology, all our warning systems, all our preparation will amount to one thing: we'll see it coming. Maybe days in advance, maybe weeks if we're lucky, but we won't stop it. Can't evacuate everyone. Can't feed billions through years of volcanic winter. Can't maintain civilization when the sun dims and crops fail. So which is more destructive in potential and scale? In inevitability? The answer is clear. But here's what keeps me up at night and what should concern all of us. It's not an either-or question. Both forces exist. Both threaten us. We've built 12,700 nuclear weapons. Enough to devastate civilization if we choose to use them. And beneath Yellowstone, beneath Toba, beneath the Toba volcanic zone, beneath dozens of other potential supervolcanoes, magma chambers continue to fill. Pressure continues to build. We live in an age of dual catastrophes, one of our own making. One we inherited from the violent geology of our planet. The nuclear threat we can control, can reduce, can potentially eliminate if humanity finds the wisdom and courage to do so. The volcanic threat, we adapt, prepare as best we can. Hope it doesn't happen in our lifetime or our children's lifetimes. And pray that if it does, we've learned enough, built enough resilience, maintained enough humanity to survive what follows. Because here's the final, sobering truth. The Tsar Bomba was detonated once, as a test, to prove it could be done. Then never again. We recognized its horror and stepped back from the brink, but Yellowstone has erupted 3 times, on a schedule. With geological regularity, and it will erupt again. The volcano doesn't care about our fears, our preparations, our hopes for the future. It simply waits, building pressure, degree by degree, year by year. Have you ever wondered what the most powerful force on Earth is? For decades, we've lived with the chilling knowledge of our own creation. Nuclear weapons. A single bomb can level a city, and a full-scale exchange could plunge our world into a nuclear winter. It's a terrifying testament to human ingenuity turned towards destruction. We build bunkers, we sign treaties, we hold our breath, hoping the button is never pushed. This is a threat we made, a monster we keep caged. But what if I told you there's another power, one that dwarfs our atomic ambitions, simmering right beneath our feet? Imagine a force millions of times more powerful than the bomb that struck Hiroshima. A force that doesn't need a launch code or a political crisis to be unleashed. This is the power of a supervolcano. And one of the largest, most famous, and most monitored is right here, in the heart of America. Yellowstone. It's not a mountain with a cone-shaped top. It's a massive caldera, a giant collapsed crater left from an eruption so colossal it's hard to comprehend. And it has a history of erupting with devastating regularity. Let's talk numbers for a second because this is where it gets truly mind-boggling. The largest nuclear weapon ever detonated, the Tsar Bomba, yielded about 50 megatons of explosive force. It was a terrifying spectacle. Now, consider Yellowstone's last major eruption, about 640,000 years ago. It ejected over 1,000 cubic kilometers of rock and ash into the atmosphere. To put that in perspective, that's enough material to bury the entire state of Texas 5 feet deep. The energy release would be equivalent to thousands of Tsar Bombas detonating at once. A nuclear war is a catastrophe of our own making. A supereruption is a planetary-scale event, a force of nature operating on a geological timescale that we are merely guests in. So what would happen if Yellowstone decided to wake up? The initial blast would be cataclysmic, instantly devastating a radius of hundreds of miles. But the real global killer would be the aftermath. A thick cloud of volcanic ash and sulfur dioxide would be injected high into the stratosphere, blanketing the Earth. This veil would block sunlight, triggering a volcanic winter. Global temperatures would plummet. Crops would fail worldwide, leading to mass famine. Ecosystems would collapse. Unlike a nuclear winter, which might last a few years, the effects of a supereruption could linger for decades, fundamentally altering our planet's climate and life as we know it. Now let's compare the two apocalypses. A nuclear war is a sprint to destruction. It's fast, brutal, and born from human conflict, ideology, and fear. It's a preventable tragedy. We can dismantle the weapons, foster diplomacy, and choose peace. The power to avoid this future is entirely within our hands. A supervolcano, on the other hand, is a marathon of geological inevitability. It's not a matter of if, but when. We can't negotiate with magma. We can't sign a treaty with a tectonic plate. It operates on a timeline that makes human history look like a brief flash. This brings up a fascinating contrast in how we approach these threats. We spend trillions on military defense, on deterrence systems, on political maneuvering to prevent nuclear war. And rightly so. It's an immediate, self-inflicted danger. But our approach to a supervolcano is different. It's one of science, monitoring, and acceptance. Geologists at the Yellowstone Volcano Observatory watch the ground swell and fall by inches. They monitor seismic activity, gas emissions, and ground temperature, not to stop the eruption, but to understand it, to hopefully give us a warning. The warning might be years or even decades, but it won't be a 4-minute missile warning. So here we are, caught between two giants. One is a monster of our own design, a reflection of our darkest capabilities. The other is a force of nature, a reminder of our small place in the grand cosmic and geological theater. The threat of nuclear war forces us to confront the worst parts of ourselves, our tribalism, our fear, our capacity for ultimate destruction. It begs us to be better, to communicate, to cooperate. It's a moral and political challenge. The threat of a supervolcano presents a different kind of challenge. It's a scientific and logistical puzzle. How do we prepare for an event that could cripple civilization? How do we feed billions when the sun is blotted out? This requires a different kind of global cooperation, one based not on preventing conflict, but on ensuring survival. Think about the psychology of it all. We fear what we can control and what we can imagine. A nuclear war, for all its horror, is a human story. It has villains and heroes, decisions and consequences. A supervolruption is an act of God, an impersonal force that doesn't care about our borders, our economies, or our lives. It's a humbling thought. It forces us to think beyond our short lifespans and quarterly reports, to consider deep time and our species' long-term resilience. Perhaps the greatest lesson from comparing these two doomsdays is about perspective. Our obsession with human conflict, our political squabbles, our national rivalries, they all seem so small when faced with the reality of a planet that can shake us off like a bad cold. The same global cooperation needed to avert nuclear war is the exact same spirit we need to survive the aftermath of a supervolcano. We'd have to share resources, knowledge, and shelter on an unprecedented scale. Borders would become meaningless when survival is the only goal. In a strange way, the slumbering giant beneath Yellowstone teaches us the same lesson as the warheads in their silos. We are all in this together. Whether the threat is from the atom or the caldera, the path forward is one of unity, long-term thinking, and a shared commitment to preserving this fragile, beautiful world and our place within it. The choice is ours. We can continue to focus on the monsters we create, or we can work together to prepare for the challenges the universe throws at us. One is a choice for peace, the other a plan for survival. Ultimately, they might just be two sides of the same coin. Thanks for watching. If this video gave you a new perspective on the world, Hit that like button and subscribe for more deep dives into the forces that shape our existence. See you next time.